This presentation's on Kubernetes Workspaces, enhancing multi-tenancy with intelligent API server proxying. So I'm James Munnelly, a field engineer at Apple, working in all things kind of Kubernetes and helping out customers.
And I'm Andrea Tosatto, and I'm an SRE at Apple, working on the Kubernetes platform as well. So the kind of idea of this talk is really to talk about workspaces. It is something that in the community we've been talking about for a long time, around multi-tenancy. But also it's something that surprised us preparing this talk is that a couple of weeks ago, someone also posted on Reddit asking what is a feature that you really want Kubernetes to be added? Of course, people have opinion around Helm, but also many of the people really were bringing up namespaces and additional concept around multi-tenancy within namespaces as a kind of topic. And that really resonated with us and is why also it's very similar to why the motivation that led us to talk about workspaces again and think about this concept. The way we see workspaces, and this is maybe also something slightly different from previous approaches, is that we really see workspaces as a view over a set of resources that are running across multiple namespaces in a Kubernetes cluster. And if we think about, this is a very simple scenario, but if we think about how teams operate in multi-tenant cluster, they tend to have a number of namespaces in this cluster where they place their own application into. And this is particularly important because Kubernetes really recommend users to use namespaces as boundaries about their application. Identity is bounded by namespaces and policies. So what we see teams especially also from our internal experience, having slowly to have more and more namespaces. But of course, this comes with toil for them, because there are no good solutions that allow to operate across multiple namespaces. Some controller, they need, you always need to update the namespaces you want to reconcile on. So the kind of idea that we have is really to introduce a kind of layer above that allow, and this is what workspaces are, that allow to group resources that belong across multiple namespaces, providing an experience which is way more similar to the one that operator or in the cluster as a service model you give, having cluster-wide permission, but still in a multi-tenant cluster. One of the big properties of workspaces, and this is also where maybe this approach is different from previous one, is that we really see workspaces as scopes at the API level, that we use to aggregate resources together, so they can potentially be overlapping. Now, this is a kind of very simplistic example, but you think about having a support team that has access to everything about production, their under tool about everything in production, while maybe the front-end team is managing their own application across all of the front-end namespaces, and these scopes can potentially overlap. So the goals for us coming up with this idea is really to kind of promote security best practices and standardization around how we operate, especially role, cluster role bindings, access, in multi-tenant clusters. In general, again, namespaces are security boundaries in Kubernetes. And what we have seen also is that because of the friction with the tooling and the lack of tooling, either different tenants start being packing multiple applications within the same namespace because it's simplistic, it's simple for them, or they really struggle also when they operate across multiple namespaces in correctly configuring the role binding because there is a separation of concerns between the cluster admin and the tenant. And this always leads to kind of challenges when it comes to self-service, the platform. The other thing that we found is because when we scale, something that we noticed is that our customer kind of try to work around the lack of tooling. We hit some scalability limits of Kubernetes, too many objects within a single namespace, which makes the experience very suboptimal when it comes to list resources, run controller within namespaces, just because there are thousands of objects within that. And also, I think something that is really missing is really we're lacking a cluster-wide, cluster scope construct in multi-tenant environments. They don't apply to the whole cluster, but apply to the tenant. And the reality in our scenario and what we notice is that the tenant is a group of namespaces, not a single namespace. All right.
Cool. Yeah, there I am. So there's been a lot of approaches to this sort of thing before. We've got controllers moving things around. You can do all sorts. As you can probably tell from the title of the talk, we're looking at a proxy instead. So this is sitting in front of the Kube API server, giving us a lot more flexibility for like mutating requests, understanding what we need to do, and adding extra context along the way. Yeah, there's been a few things in this area before. Hierarchical namespace controller. Has anyone heard of that or seen that in this space? Yeah? So this came out of a working group Multi-Tenancy a little while ago. This was all about kind of being able to create arbitrary hierarchies. It doesn't try and solve for access to different, to these different hierarchies and things. There was some early experimentation into this a while back. But largely, it's trying to define the models, like the language and the APIs that we use to express that. We've also got the idea of like syncing resources between clusters, and I think that's actually quite a distinct space because that's, I think that kind of touches on multi-cluster, whereas here we're talking about multi-tenancy. And I think the two kind of get a little bit mixed. You can run your virtual clusters within multi-tenant things, and then it is a multi-tenancy construct in a way. But ultimately, when it comes to syncing objects, to me, that's a multi-cluster concept. And I think it also comes with its own challenges too, especially for interoperation of like existing controllers working against existing clusters and things kind of moving to this new world. I think it's a difficult migration path. So yeah, what is the proxy doing here? It provides a cluster-like abstraction into multi-tenant Kubernetes clusters. That isn't trying to give you arbitrary APIs. It's not trying to give you, your own node objects or anything like that. This is just views into existing clusters. One of the key things here for us is actually making sure that we maintain compatibility on the API level with existing kind of API constructs and everything else. So that includes, one of the goals here is to be able to run a full conformance suite against a cluster exposed through a workspace with like a subset of the namespaces on there exposed. So jumping into the demo, because I think it's best to, thank you. Jumping into the demo here, because I think it's always best to lead with that, and then we can go into some more details. So what we've got here is a kind cluster running in the background, which you've probably all heard of. So if you see here, I've got a number of namespaces, pods. This is effectively your super admin view. Nothing's fancy going on here. And you can see we've got these different teams. Teams, backend database, team, front-end dev, front-end prod. Apply your own organizational structure to this. This is for demonstration purposes. So normally, people would be able to access either at the cluster scope or individually by doing -n and listing things. What we introduce, though, is a new type. Here, if I talk via our proxy, and in the proxy, we introduce this new type, workspaces. So a workspace, at the bottom, you can see it's got a name and a list of namespaces assigned to it. Now, this is all constructed from a selector. If I quickly jump in here and show you some YAML for that, you can see, and I guess I should note as well, by talking via that -- context proxy, all I'm doing is pointing at this local, it's in this top terminal here, this layer that sits in front of the API server. And on here we have a spec with a selector, and we have a controller running that expands that out into a set of namespaces. The exact semantics for this, I think, I'm very, very, very open to discussion on how we model this kind of configuration, but yeah, this is how we got it right now to kind of demonstrate the point. So within here, we can see in our team front-end workspace, you can see we've got 2 namespaces listed. So if I now update my so instead of just going via the proxy, which is kind of going to the root of the configuration store, this is more just so we can quickly see. Obviously, you'd probably configure your actual kube contexts with individual tenants to point to these API server endpoints. And this is very similar to how KCP has kind of modeled its own access and things. You give people access to their own endpoint. But when we do this, you can see we start making queries against the team backend, and we get a filtered view back. Here, you can see the namespaces that are assigned, I guess, just for consistency. If I change that there, you can see we get a different list depending on the view that we come in through. Now, this is the same object. This is the same resource. There's no syncing going on. We'll go into details on exactly how all of this comes together. But you can see this offers a very neat scoped view that you can go and attach your controllers to. You run your controllers against this endpoint, and everything kind of just works. And to demonstrate that, Andrea is actually going to show you all of this within a controller running.
Yeah, I mean, if you guys are, I guess everyone knows about sample controller, but what we did just to demonstrate like this kind of concept, like we really took something like from the community. Like an example is really taking the sample controller. This sample controller is having like a custom resource type, which is called foo, and it's creating like a deployment out of like foos. So what we really want to demonstrate here is the fact, and first of all, the controller is operating on a cluster scope. Like foo is a cluster, is a namespace resource, but the controller is operating and watching foos across like all of the cluster. Like the kind of thing that we did, and we did a little bit like of a hack here, like just to point it, like do the proxy, but it's essentially like the open source code. And what we want to do here, we want to run like a foo against like the team front-end workspace, just to demonstrate and show like that this is fully interoperable. From the point of view of the client, there is nothing that needs to be done here, because essentially it's just like a new endpoint that provides them a cluster-wide view on the cluster from the point of view. But through Workspace, we can scope the resources and the access like specific to the namespaces that are included into the workspace. So if I cut like if I look at, for instance, a potential configuration here, what we are doing here, we're creating essentially like two foo resources, foo dev and foo prod, one against like the dev namespace and the other one against like the prod namespace. What we want to show here is essentially that this controller is operating at the workspace scope, and what it's going to do essentially is going to be able like to just reconcile both of the resources. And yeah. All right, perfect. So if I look at the proxy, like the foos here, like you can see essentially like that this is just at the, I'm eating the cluster, I'm not doing anything workspace scoped. You can see already like that, like there are like two foo resources like for the dev and the prod namespace, and this has resulted in the creation of two deployments. Like these are running like the Nginx image, like it's just running right now. So this controller essentially has been able like to kind of like scoped like to the front-end workspace, being able like to get the resources and to demonstrate and create the resulting deployment in the namespaces where they belong to. And to demonstrate the fact that this is scoped like to the workspace, what we're going to do next is we're going to create exactly like a similar resource, and this is going to be created against like the backend namespace. So if I were to apply like this resource, like for instance to my cluster, and I were to run again like the previous command, you will see now that I have like a new foo created into the backend, but because the scope of like this, the reconciliation of this controller is only the front end namespaces, like I won't be able, like the controller won't be able like to reconcile this resource. So this is really to try to demonstrate like the concept that we're trying to push here. And you can think about many applications, like in multi-tenant cluster, for instance, observability, running metric server, like people tend to run metric server in an individual namespace, or tend to use kubestate metrics in an individual namespace, or tends to use kubestate metrics and pass a list of namespaces. Prometheus, similar story there. This really allows us like to have a pattern where we kind of enable like teams to self-manage like namespaces, as well as potentially running controller that operate across all of the scope or their API. All right, back to James.
Cool. No? Yeah, I'm back. So yeah, we've shown quite a lot here, and I think kind of jump straight through. So I'm going to kind of take a step back and talk about how all of this is put together, because yeah, there's quite a few things. So first and foremost, we have requests coming in from users. They go via the proxy. We need to do some form of authentication. We need to do some form of authorization. We don't want this proxy to be doing anything like specifically just in the proxy. Like we want to we don't want to create like a 2 tiers and 2 layers where you can actually access more if you bypass the proxy versus if you go via it. So almost everything is delegated to this like back-end cluster, as it were. So authentication, token comes in, we go and make a call, just delegated authn to the actual target cluster in order to authenticate the user. As we go through, we also do authorization. This is built on the Kubernetes API server like framework and libraries. There are, I think there's, we can change up how all of these kind of things go together, and I'm very keen to work with the community to work out what the best way is. But by delegating all of this, it makes sure that we don't end out having some kind of split view in terms of like what access that you can get. When it comes to actually forwarding the requests on to the API server in the backend, we use API impersonation, very similar to Kubeaggregator, although that uses request header authentication, which is a little bit trickier to get working in kind of arbitrary cloud environments where you don't have control over API servers. So impersonation is used here. I'll jump through in a minute to talk about why we actually need that and not just passing through tokens, but it also means that we can do things like terminating MTLS at a proxy and still then have requests passed through. Yeah, and I think, as I said there before, minimizing the responsibilities of the proxy to make sure that we're not creating some kind of new attack surface or anything like that. And this is very much, the intention here is to be able to layer this on top of an existing cluster and actually kind of like very easily transition across to using it, or even have like a hybrid model where you have people working within individual namespaces still in these backends, whilst you've also got these cluster scope views. So it shouldn't be one or the other. So kind of going into how requests in Kubernetes work, I don't know how many people run their kubectl with -v8 or something particularly often, but you have here like a normal request, if you're doing a cluster scope list, goes to /API/v1/pods. That's going to give you everything. So when we go and make a similar request in Workspaces, we want to really minimize how much work the proxy has to do. And so for that, we've gone and taken an approach using selectors. And this is requiring a few changes, which we have kept in the works for, which I've got some links to details on at the end of the deck. But we're basically relying on field selectors within set operations. Anyone who's really closely paying attention may know that's not supported today. So there's a few extra bits in here that we've done to, well, use or abuse label selectors to do a similar thing. But field selector support for, like with set operations is something that's kind of integral here and something that we're looking to contribute and add into core Kubernetes. So there are a few changes here going on. But as you can see, a request comes in for something like /workspaces, my workspace, and then beyond that, it's very similar to what we see before, API v1 pods. This is, again, a technique borrowed from KCP. Does a very similar thing, but with clusters instead of workspaces is the term. But ultimately, the proxy needs to be aware of, I think actually the next slide, this is the best one for this. Yeah, the proxy, no, I'll jump by there. The proxy needs to be aware of this mapping between a workspace and a set of namespaces. So it's watching these workspace objects that we showed you previously. And it converts my workspace into a set of namespaces to actually do a query on. Now that's really important for things like watches, because a watch, we need to make sure we've got linear events coming in order and maintaining all those guarantees. And frankly, I also don't want to be having to get anything involved with maintaining linear orderability of events and things like that. Merging event streams and stuff is just not really going to be feasible for getting this actually done sometime before, without atomic clocks or something like that, I don't know, and a lot more work. So we're really trying to push as much as we can as possible back to that backing server. So all of this is actually built on top of Kubeaggregator right now, which is, again, quite different to some of these other implementations where we actually bring up stores, interactions with, the request body even. Like we're purposely trying to avoid decoding objects, re-encoding objects, or anything like that, because if anyone has ever touched on API server scalability, which if you're in a multi-tenancy talk, you may well have done, that's a very, very expensive part of the request flow. And so here, we're just modifying HTTP query parameters. We take, and the path string. We take /workspaces my thing, and we go and change that into something with a field selector on and forward it on. And that keeps it really, really nice and lightweight. It means we're back in the world of HTTP proxies with a few extra intelligent bits to know how to map workspaces to namespaces. Now, the one thing we haven't really touched too much on here, though, is authorization. And for that, we have the idea, for authorization, we have the idea of cluster roles and cluster role bindings. That's obviously going to be a bit tricky in a multi-tenant environment because we can't have people going and creating cluster roles and cluster role bindings. So we've come up with the idea of having, and borrowed from HNC again, of having one single namespace assigned per workspace where we store workspace scoped objects. So I'm going to use the term workspace role binding, but we expose them to users as cluster roles and cluster role bindings for API compatibility again. Now to do that, the proxy does have to do a few extra steps because cluster roles are not workspace roles, even if they look identical, or even if we call them the same thing. So for that, we have a few extra steps where we actually intercept the request, we do decode cluster role or cluster role binding, and then using kind of standard Kubernetes conversion techniques, we actually then go and convert that into the namespace scoped equivalent type, set the workspace cluster scoped resource namespace. Naming is still hard. We go and set that onto the object and persist it in the backend. And then when users go and do a read, a list, a get, a watch, on the fly, we're doing those same conversions back to the users so they don't actually have to see that. What that means is users can do a get cluster role binding, create, apply, whatever they want to do. We go and do all of those, we handle the complexity and we expose it to them. Now, that also has to, well, yeah. You can see, I guess, on the request flow here, a request for workspaces, my workspace, APIs, blah, 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 blah. It then results in a request to a similar request, but within a particular namespace, in the cluster scoped resource namespace. And please, I really want your input on all of this naming and stuff, because it's confusing, and this is the simplified version. But there's a few nuances with that, right? Like we are now encoding, decoding objects, managing them. So these are a bit more expensive. This is also specifically the reason why we don't do it for all the other object types, because cluster roles, cluster role bindings, there's less churn on these types of resources. Pods, events, all of that gets a little bit scarier. There's a whole load of requests going through. This, storing namespace, cluster scoped objects within a namespace is one way that we've approached it. We could also utilize like an etcd attached to the proxy to do that. There's different approaches that we can go for storing these sorts of special objects. We are specifically, though, like not trying to allow people to attach arbitrary new types and things, so we're keeping that list of workspace scoped things relatively small right now until we can kind of really mature this. Yeah, authentication, as I say, delegated to the backend API server. The one thing we need to do, though, especially when it comes to authorizing later on, which has to be done in the backend cluster again, because we don't want to expose a security vulnerability, we pass along the workspace name that they've authenticated through in that impersonation header. Now, that gets consumed by the authorization plugin. Now, there's a few different ways that we can do this. For now, we have, as I say, an authorization plugin that is workspace aware. It can see that user info. It can extract the workspace name out of the user's metadata, and then apply the RBAC authorizer, just like normal, so using standard upstream kind of RBAC authorization code to assess whether that user can make that request, given the scope. If anyone's been following along all the various different authorization topics at this KubeCon, of which there have been many, many different talks, we've been having a lot of conversations here too, because an authorization plugin works well. We're not actually re-implementing auth-z ourselves particularly much. We're leaning on RBAC almost entirely and just changing the kind of context of the roles we use to authorize each request depending on how it comes in. But we are very, very interested in different ways that we can utilize some of the stuff with CEDA that's been going on, RBAC, all of this, to see if there are ways that we can actually do this in a even more lightweight way. Yeah. Scalability properties of this, I think, as we've already mentioned, those workspace scoped objects are probably the more problematic ones because we actually have encodes and decodes going on. Cluster roles and cluster role bindings is pretty much what is it for what we actually expose through there. So 99% of your traffic, all the rest of your traffic, is pretty much handled like normal. We go and take the request in, we rewrite the header to begin with, and then just forward it on. So we're not really seeing so much we're not seeing too much change there at all. The one thing to note, though, as I said before, because we're pushing this down to the back end, that filtering logic, that set operation thing, we do need to make sure is fairly efficient, because otherwise, API server, watch caches, and things like that, we need to make sure that it's able to performantly return objects when you're doing label selector queries. So the field selector set operations is one part of that. We've got further patches to that once we actually have field selector set operations merged to actually make that more efficient again. One of the key things, though, is we do not want to be hitting etcd for all of these, because otherwise it is ultimately a cluster scoped request with a filter on there. The last thing we want to be doing now is saying, well, the API server is going to have to go and decode every object. So this is, I think the likes of the recent consistent reads from watch cache, that feature is going to be pretty integral, especially for your kubectl users wanting to do consistent reads, because by being able to serve them out of the cache, the API server avoids having to decode all of these objects again just to throw most of them away, and it can actually very performantly respond to these queries. So yeah, we've got a whole bunch of benchmark tests to put together, and actually want to get these into core normally, and then kind of do these before and after with and without comparisons. So yeah, as promised, there's a few of these next steps. I'll make sure to share these slides so you can jump in yourself. Extended operations in selectors is one, and there'll be a kepping coming for that. This is the allowing watch clients to request watch bookmarks. That's actually something from an original design where we were instantiating more caches per resource type. That also itself became a scalability problem, so it's not essential for what we're doing here, but yeah, it's something I think is worth noting, because we did mention on the talk description like multi-tiered caching and things like that. If ever we were to go down that route and utilize the same proxy design, I think that would be a particularly useful thing for us to be able to go and serve consistent reads away from core API servers. But I think at this point, this is a nice to have and not a must have. Detailed design documents is probably a good one. We want to be opening this. We're opening this as a project within the Kubernetes SIGs repo and trying to find a home within either CAPI machinery, SIG-auth. I'm very keen to make sure that we're developing this with the eye of the community over it. I don't want us to be, especially not authorization mechanisms, I don't want us to be recreating the world. So yeah, there's a whole lot to put together there and get written up and detailed and put together in a proposal for one of the SIGs. So yeah, we've got a few minutes left for questions, but thank you very much for coming along. We've got a microphone up here if anyone wants to jump up. Otherwise, yeah, there may need to be a queue. We've got 7 minutes. We do have time for questions, otherwise we can wait outside.
Hello. CRDs come into picture for this at all?
CRDs. So, yeah, it's a good question. It's usually the first question we get asked, as it's here. It's something we kind of like, when I first started on this, I thought that would be a great idea. As we moved further along, it became less of a good idea, because you end out with problems with garbage collection. If one object owns another, and you've got CRDs that exist within a workspace, we don't want to be modifying that backend cluster. And if the backend cluster isn't aware of the workspace, it won't actually be able to understand those CRDs, and so it's going to start deleting objects that are owned by CRDs that don't actually exist like normal in the backend cluster. So no, I think is actually quite a concrete answer to it. I think like KCP touches on doing exactly that. We can bolt on KCP concept to this, but I actually think we're better off keeping this as like a fundamental building block. And then we've been looking as well at using things like KCP's virtual workspaces and mounting and things, and also looking at overlaying possibly resource types. But I think for this particular part of it, no, CRDs I don't think really fit there. We don't want to be doing custom API surfaces. We're just trying to expose the APIs that already exist in the cluster, but with a new authorization boundary, a new scoping boundary on top, if that makes sense.
Yeah, I got just a couple of questions more.
Could you just come a bit closer to the mic? Sorry.
The cluster, the workspace RBAC, does it override the namespace RBAC?
No, it complements.
No, it's just on top of that, right? Like, so it gives you today, like if you want to give access, like especially because scopes are overlapping, imagine that you have a team, like the observability team, that runs their own observability and things like that. Right now, like very often, like the model that this is implemented is having like cluster-wide permission. Now, this allows us like to give boundaries like to the scope they can operate in, be in the workspace, and have like tenants opting into the feature, which is like the reason why overlapping scopes also are important. So the idea is that you add it on top of the current like role and role binding that is essentially workspace role and workspace role binding that allow you to define the equivalent of the cluster role and role binding, just scope to the workspace, essentially.
Yeah, it's worth noting there that you can still do like namespace scoped requests through your workspace just fine, and then authorization works. Well, it actually works. You get your standard roles, role bindings applied, and then if you don't have permission there, your cluster roles, cluster role bindings from the workspace.
Yeah, also the proxy like is probably something in the demo like we should have like mentioned more in detail. The proxy is a transparent proxy, as you notice. This is really like something we're really kind of like trying to do as much as possible in the design. So you can still operate on the namespace boundary. You just like choose through your context which scope you want to operate on, the namespace or like the workspace.
Cool.
Thank you. Awesome.
Thanks very much.
Hey, thanks for the talk. So my question's around observability pipelines. If you think like you're breaking your cluster up on a team-by-team basis, how do you think about, like OpenTelemetry collector, metrics logs, traces, profiles going through? If it's within a workspace, are you then having to, instrument an observability pipeline within each individual workspace, or are you thinking about, pushing up to like a central cluster level collector? Would you break out of the workspace?
It really depends on the architecture. Like I think like this is something that we're looking at. Look at teams. Teams like often like they need to run like their own observability like collectors like to get the metrics from the application and then like kind of like push them like to centralized observability like solution like whatever people like are using. Like the reality of it like is that in a multi-tenant environment, like they need to run multiple instances of this collector each on each namespace. The idea with the workspace is that you can think about having a namespace where you deploy all of your observability tooling, and this, like the controller, uses cluster-wide permission to have access essentially or cluster-wide request, which we translate to workspace scoped request to have access to all of the different applications running in all of the namespaces. You can think about having like a team from TED observability namespace where you run like your own like OpenTelemetry collectors, and these collectors are discovering like all of like the application that are running and able to scrape them. That's essentially like the way we think about it, and it's a common use case. Like I was mentioning kube state metrics, this is also something that happens. Like you can have kube state metrics exposing your own like pod metrics across the whole workspace versus running many of them, or have like the observability team having to run one for everyone like in the cluster. That's essentially the idea there.
I think the only other thing to note here as well is, like I say, this doesn't replace or get rid of any existing functionality. If your architecture is you've got some super massively scalable already multi-tenant controller that actually does observability across the whole cluster, you can still run that against the whole cluster just fine, and that would interoperate. If you want, what we're trying to do here is kind of shift teams from having to run one per namespace, and then like actually shifting up to the workspace to make that configuration easier.
So if I can play that back, it sounds like you've got the option. You can either have one workspace where everybody could ship all of their OTLP stuff into and forward it out from there as like a single instance, but you've also got the option of like a per workspace as well.
Yeah. Exactly. That's the idea there. And again, like is an additional dimension to the cluster-wide or namespace-wide. Like now it gives you an option, and it really depends on what you want to do there.
Previously, you just had that or that. Now you got that.
Great, thank you.
So, are you guys planning to expand this to things like network policies? Because I am envisioning this as if we want to support multiple groups where each group has multiple users, right? And there are a set of things like a storage class, a network policies which are dedicated to a group. So can we just apply it to the workspace and assume that gets hierarchy or filtered out to every member in the group?
So that's a good question. So there's a few things in there. Storage class, and we've got 30 seconds, so I'm going to have to race through this and then answer the rest outside. Storage class are cluster scoped resources. We're not trying to provide all these alternate stores, no. It's something you could, The architecture would allow you to have a workspace scope storage class, but things get very funky when you think about kubelets and everything else, because all your kubelets, they still work at the cluster scope, the real true cluster scope, and that's kind of essential. Network policy, they're namespace scoped resources. They use labels, though. All of what we've done here is all based on labels. We can, as I said before, that's not required. We can kind of change all of this up too. But that's interoperable. The hardened boundaries, though, that's something we need to work out. I've got a big red exclamation mark here, though, so we need to continue this conversation out back. But thank you very much, everyone, for coming along.
Thank you.